All right, good day. Let's look into this organic chemistry question that says, name this organic compound. Now, there are some basic things we need to understand before attempting a question like this. The first one is to establish the longest continuous chain of carbon. The second one is to identify the functional group or groups present in the compound. The third one is to also identify other substituents which are not functional groups. And the last one is to give names using alphabetical order and priority. So let's start. Now, here we have 10 carbon atoms. Organic chemistry gives you the chance or the opportunity to count from anywhere as long as you are maintaining the priority in this. It gives you that chance to count from anywhere. So, but make sure that at the end of everything, you must obey the longest, you must meet the criteria of the longest concentration of carbon, the substituent, functional groups, and other criteria. So let's count this way: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here we have 10 carbon atoms. If we try to take other ones, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this way will give us 9, but straight will give us 10. So 10 is the longest. We have to take 10. Now the second thing is to check, where do we count from? Do we start this way or this way? Now, if you check from this way, you find out that these functional groups and substituents, they are farther from the left and closer from the right. You find out that these functional groups and substituents are closer when counting from the right than the left. So our counting begins from this. So this carbon 1, carbon 2, 3, 4, 5, 6, 7, 8, 9, and 10. So in chemistry, 10 is represented by what? Deca. Deca or decay, but this is not an arcade. So let us use the word deca for 10. Now, since this is our carbon 1, and we have OH on carbon 2, and another OH on carbon 2. And remember that for alkanol, OH is alkanol, and the suffix should be what? Ol. So we have 2 ol. 2 ol because alkanol is on carbon 2. We still have another alkanol still on carbon 2, so we have 2 ol. Now, this is carbon 3, there is nothing on carbon 3. On carbon 4, we have ethyl. Ethyl from the word ethane. But this is not alkane, it is alkyl, so it is ethyl. So this is ethyl. So on carbon 4, we have 4 ethyl. So we have 4 ethyl. Still on that same carbon 4, we still have another ethyl, which gives us another 4 ethyl. Now on carbon 5, we have CO. CO is alkanol, and the suffix is ONE, which is phone, and it's on carbon 5, so we have 5 O from the word alkanol. Now on carbon 6, we have 1 carbon attachment, which is what? Methyl, coming from the word methane or 1, C1. So this is methyl because it's an alkyl member. So we have 6 methyl because the attachment is on carbon 6. Then 7, 8, 9, and 10. There is no other substituent or functional group there. So now let's use this to form a name for this compound or to assign name to this compound. Now remember that we have deca from the word 10 carbon atoms that comes from the word decay. And we have functional groups. These are functional groups. These ones are functional groups. This is the functional groups. This is the functional group. While the rest are substituents, alkyl substituents. Now we have to apply alphabetical order in assigning name. Let's apply alphabetical order. We all know that E comes before N. So the name of this compound will be 4, 4 diethyl. Diethyl for this ethyl. Then the next is methyl. 6 methyl. Then deca. Let's continue from here. Deca. We have alkanol of carbon 2. 2, 2 diol 5-ol. So this is the name of this compound. So the name is 4,4-diethyl, owing to the fact that on carbon 4 we have ethyl on carbon 4, we still have another ethyl on carbon 4. And the total number of ethyl we have in the compound is 2. That's where the di is coming from. Now on carbon 6, this carbon 6 we have in ethyl. Deca simply means it has 10 carbon atoms. 2,2-diol means on carbon 2 we have alkanol on carbon 2 and another alkanol on carbon 2. So therefore you should carry the word di. 5-ol simply means alkanol on carbon 5. And the name must end with "ol" because in order of priorities, ketone or alkanol is greater than alkanol. Thank you very much.